Hi everyone. Today what we're going to work our way through is a quadratics problem 2. So I'm hoping that your practice from last day went well. And what we're going to look at are two different types of applications today. Specifically, we're going to take a look at a financial application, and then we're going to take a look at a little bit of an engineering application. So let's pause the video right now and you give problem 1 a read. Okay, we should be back. So, I'm hoping that problem 1 sounds somewhat familiar because in grade 10 you went through a financial application that dealt with revenue. And so, hopefully we're good, or we should be good, that revenue is the amount of money that comes in from something. Has no relevance to what goes out of a business, but it's the amount of money that comes in. And the two determining factors for what come in are price and quantity. So for us to calculate revenue, we would take our price and we multiply it by the number of units sold. The second part to that would deal with profit. And when we calculate profit, what we're actually talking about is the amount of money that comes in, revenue, subtract the amount of money that goes out, cost. And so as we work our way through those applications, we have to be careful that we don't use the term how much money we make. When we say how much money we make, that can often get misinterpreted as profit. So what we have to be careful of is, are we talking about revenue, just the amount of money coming in, or are we talking about the difference between what comes in versus what goes out? Okay, now that we've got that drawn back from our background, let's take a look at what problem A asks specifically. It asks us to determine the number of students who have to go on this trip for Josh to break even. And we should be good that break even, because we've talked about this before, means profit equals 0. So for us to answer problem A, we would have to come up with a profit equation or function, and then have that function equal 0 to create an equation. So for us to build a profit function, we need revenue minus cost. And so for us to come up with the revenue portion, we need price times quantity. And although I would love to have a big drawn out reason and a way for us to kind of work, unfortunately, this is one of those ones that you just kind of have to remember how to begin. So I want to zero in on a couple things in the problem. And notice that it talks about an increase in price, then causing a change in quantity. And anytime we see those types of problems, we have to just kind of remember our beginning point. And what we're going to do is we're going to let X represent the number of price changes. Notice I didn't say price increases or I didn't say price decreases. It's just price change. And I'll allow whether I add to that or subtract to that to dictate the direction. As soon as I come up with that blue statement, I would strongly recommend, and I mean strongly recommend, that you create the next two then statements. As soon as I say that X is the number of price changes, then I can come up with an expression for the price. That is, right now, or last year, the last time we dealt with this, the price for each student was $550. But what Josh is talking about is possibly increasing the price, $50. So that means that I can add to that the increase of $50 per price change. And that expression of 550 plus 50x, that is the price. Well, I now have an expression for price. I need one for quantity. And so then, well, at that price of 550, we had 25 students go last year. So 25 would be my starting quantity. But now my quantity is going to change. And I notice that I have 2 fewer students. So I'm going to subtract 2 for every price change. That is the quantity. And you'll just see me use my short form QTY. Now that I have those then statements, I can actually go through and build a profit function because I have the ability to now construct a revenue expression. So now is where I'm actually going to jump in with the specifics of A. What I'm looking for is profit equaling 0. So let's build a profit function. Okay, my profit is revenue minus cost. So I have revenue minus cost. Okay, what's my revenue? It's price times quantity. So I have a price of 550 plus 50x times a quantity of 25 minus 2x. There is my revenue. Now what I need to do is subtract my cost. But I want you to take a look closely at your cost information. Okay, first off, you'll notice that we have to pay this flat fee of $5,500. It's a flat fee. So it doesn't matter how many students travel, we're paying that much. Secondly, we have this per student fee for hotels and lift tickets. $240 per person. Okay, so what would be my total cost then? Well, my costs are going to be made up of those two components. $5,500 for the bus, flat fee, and $240 per person. Well, how many people are going? And you'll notice we already had that expression written down. There is my quantity. So I have 240 times the quantity of people that are attending. There is my function. Now it's my job to solve for when profit equals 0 to get my break-even point. So my profit equals 0, and we should be good to expand those brackets on the right side, collect like terms, and see what we have. Now, just for discussion, I'm going to leave this left side as a P for right now, just for discussion on some possible mistakes we can make as we work through. Okay, so if I calculate that, that's a 13,750. I'm now going to have a minus 1,100x plus 1,000x, or 1,150. And so therefore I have a plus 150x. I then have my minus 100x squared. I can then expand those brackets at the end. While I'm expanding this in, I'm then going to subtract it all in one go. So 240 times 25 should give me a 6,000. Let's subtract that cost. And 240 times negative 2 is going to be my 480 or negative, so let's subtract that cost. There's all my brackets expanded. Now I'm going to collect like terms. And as I collect like terms, I'm going to write it in standard form as well, just to make sure that I'm good with my values. In standard form, it's recognizable for me. And so as I work my way through, I think we should get down to that. Okay, the reason why I held off having that left side be equal to 0 is because I just want you to imagine right now that I had asked a question for us to go through and deal with something a little bit different. I want to make sure that we're good that right now I cannot divide out that 100. I cannot divide out a common factor of 10 because on the left side of my equal sign, I have a P. And if I chose to divide out a negative 10, for instance, then I no longer have a profit function. I have a profit function divided by negative 10. And so we have to be very careful when we choose to reduce some equations or simplify some equations to be able to solve. As it's written right now, that is a function. However, what you saw in red is since my profit equals 0, then I really have an equation that I can solve. So my hope is, and I'm just going to come up in here for a little bit, that we would go through it, at least divide out that common factor of negative 10. I can divide it out because I have constants on both sides of my equal sign. And I get down to that point. I had the ability to solve that relatively quickly because I can use quadratic formula. Negative b plus or minus the square root of 63 squared minus 4 times, there's my plus because I can see my negative constant. 40 times 225, I think should get us to 90,000. And then that's all over 2a. So we do a little bit of cleanup and we collect what's underneath those, or that square root symbol. And now we can go ahead and we can come up with our approximates. And so we're going to get, for the positive case, approximately 8.84 for a value of x. And for the negative case, we're going to get approximately negative 2.54. Hopefully that matches up. Okay, we haven't answered the question yet because the question says the number of students who must go. And so I just want us to notice that what we've solved for is the x value. And what was x? That was the number of price changes. We've just solved for the number of price changes that is going to allow Josh to break even. And so what we need to do then is to go through and sub in those values. So, and I'm just going to shrink this down a little bit just to make a little more room. That now we can go through and we can sub in an x value of 8.84 back into our quantity expression. Our quantity expression was 25 minus 2x, and so I can replace that x with 8.84, and we should get down to 7.32. And I'm just coming over here for a little more room, or we have the other case where my quantity expression would be 25 subtract 2 times my negative 2.54. And that's going to get me down to a 30.08. So I actually have two answers to this problem. When can Josh break even, or what's the number of students? Well, we could have, and since we have to have a whole number of students, 7 students or 30 students. Now, that should make sense a little bit. That is the idea that we could have two possible answers for that. That maybe we go through and we drop the price. And so therefore, we happen to have fewer students go. Let me clarify. That we go through and we drop the price, and therefore we have more students who go, and that enables Josh to break even. Or we increase the price, which causes fewer students to go, and therefore Josh breaks even. So in this case, for the answer today, we have two different solutions. Okay, so let's tackle B now. So I've just kind of cleared off a little bit on the screen so we can make a little bit more room to work our way through B. I do want you to notice, though, that when we tackle B, which asks the question, determine the price to charge each student that will maximize profit. In order to maximize profit, we need a profit function, and so all of that work that we did in A, we're going to need to be able to tackle in B. Now, we do notice that we've been asked to maximize profit, and because this happens to be a quadratic, then we know that for our maximum profit, our independent variable x has to equal negative b over 2a. Now, this comes up with another important point of make sure that we're not dividing out a common factor. Notice I do not have an equation in purple. I have a function. And so even though I see a common factor in there, I just have to leave it in there. And so I end up getting to the point then where x is going to equal negative 630 negative b over 2 times my a. And when I go through and I calculate that, I'll actually get an exact decimal of 3.15. Now, what that x represents, x is my number of price changes, that tells me the number of price changes not the price. And so now I need to sub that x value back into my price expression. So I'm just going to write out price so I don't mistake that for profit. My price is going to be $5.50 plus $50 per price change. And I notice that Josh is going to do 3 full price changes plus a bit. So as we work our way through, that's going to give me $5.50 plus $157.5, and that's going to get me down to a ticket price of $707.50. And there we go. So a little bit more complex than what we're used to in the past. So we're used to dealing with some revenue questions, but now we've got a little bit more in our background, we can work our way up to some profit functions. So one case going through solving an equation for it, the other case having to go through and find a max or a min. Okay, let's jump into a second application. Okay, and so our last application, what we're going to look at, is something that kind of goes a little bit from an engineering standpoint. So what we want to talk about is some physical structures. And in this case, when you read the problem in 2, we're talking about a tunnel. So pause the video, give the problem a read, make sure we're good. Okay, we're back. And so as we work our way through on this, one of the first things I would say is let's draw a picture of the tunnel. And so if I was to kind of stand there and look through the tunnel, then that might be my tunnel. It says it's a parabolic arch, and it tells me that it's 12 meters wide. So that means that at its widest is 12 meters. Okay, it also tells me that the height of the arch, 4 meters from the left edge. So 4 meters from the left edge, the height of that is 6 meters. Okay. Can a truck that is 5 meters tall and 3.5 meters wide pass through the tunnel? So by just constructing that diagram, I think we could probably answer the question. One key concept for us to remember is that parabolas are symmetrical on the axis or on the vertex. And so you have that axis of symmetry that's going to run directly down the middle of that parabola. So what that tells us then is if the height of the arch is 6 meters, 4 meters from the left, then if I was to go 4 meters from the right, it would also have to be 6 meters. And so a really quick check then on that diagram would be, well, if I take away 4 from one side and 4 from the other side, then what I have left in the middle is 4 meters. And if you're asking me, can a 5 meter tall truck fit in there? Then the only thing I have to make sure of, since I can clearly see that it's at least 6 meters there, is how wide is the truck? And since that truck is only 3.5 meters wide, then clearly that truck could fit. Now, if that truck had have been wider, then maybe not. If the truck would have been taller, then maybe not, and we'd have to examine it. But given the information in the problem, we can tell just by constructing that diagram. So that diagram becomes super useful to us. Now, what I want to do is I want to be able to work our way through that diagram with a little bit more presence, and we should be okay. So the next thing then is let's jump back to that problem, and I'm going to change a little bit of information in the problem for you. We're not going to say that the truck is 5 meters tall. Let's use 6.25 meters tall. Okay, now can that truck fit? So the first thing we know that it's 12 meters wide, and we know that 4 meters in from one edge, we are 6 meters tall. Now I don't really know. Okay, how can I go about then using this? Well, the first thing that I want us to kind of have in our background is we're really good with algebra. We actually are, and even depending on your confidence level with it, you're pretty strong with it. And so we should have opportunities then to be able to use that as a background skill. And one of the ways we can do that is we can put a grid on that diagram. That is, we can take that shape, which just looks like an arch right now, and we can actually put a system of coordinates on it. We don't have to physically draw a grid over that whole shape. No, we don't need that. But what we can do is we can simply label something with a set of coordinates. And so maybe when I take a look at that, I might want that bottom side to be my origin. Doesn't have to be. I can pick any point on there. But I want to pick a point that's very obvious, a point where I don't require any estimating, one where I know the position. And so the bottom portion of that arch, I know. Well, as soon as I define the origin, then I can list a series of coordinates on that shape. Since the arch is 12 meters wide, then I know that that point must exist at 12, 0. And I do have that information about 4 meters in being 6 meters up, that I do know then that this point has to exist at 4, 6. Now, you'll also notice, given our previous discussion, that I would also know another point over here, that I would have to be 4 units to the left of that and 6 units up as well. All of those points I can label really quickly on my diagram. And I can actually label one more thing. I do know something about the coordinates of the vertex. Because my parabola is symmetrical, I know my vertex is always halfway between horizontal points. And so, since I have 0, 0 and I have 12, 0, I know that halfway between that has to be 6. And so I do know, I would like that to be in green. I do know that coordinate of 6 has to be the x coordinate of my vertex. I just don't know the y coordinate. You'll also notice that halfway between my horizontal points, my x coordinate of 6. Okay, now that I have that diagram, I can start to go through the process of trying to build as much as I can of that function. And one of the forms that I can use as I deal with my parabola is my vertex form. And we should be good that your parabolas can be written in that form. And we know that within that form, you happen to have a vertex at HK. And so what I can do is I can start to sub in what I know about that. And in vertex form, I know then that my H value must be 6. Okay, well, that gets me only so far. However, I also have to remember that all my points represent rules. That they say that if x equals this, then y must equal that within my function. And so what I can always do is I could sub in any point. So I'm going to sub in 0, 0. That tells me that when x is 0, my y value is 0. And so I'm going to replace those. Replace my y with 0. Replace my x with 0. And you will notice pretty quickly that you come up with an equation with 2 variables. And anytime you come up with an equation with 2 variables, we should almost have this instinct that starts to kind of call to us in our ear that says, yeah, but if I had another equation with those same 2 variables, I could solve the system. Now, one of the key things for us to kind of make a note of, and please do not do this, is that we could also say, well, I'm going to pick 12, 0 then as another point, and I'm going to sub that in. I just want you to notice one key thing. You get the same equation. Now, since we got the same equation, that becomes useless for us in our goal. Why do we get the same equation? Well, it comes back to the fact that we used 0, 0, and 12, 0 to determine that the x-coordinate of our vertex was 6. We used the fact that the vertex had to be halfway between those horizontal points to come up with the 6 as our vertex value, our x-coordinate. And so when I subbed in 0, 0, and then chose to sub in 12, 0, I'm actually duplicating the relationship. That I could have used either 0, 0 or 12, 0 as a useful point. But once I used one of them, the other one was really no use. So let's get rid of all that work. That doesn't mean that I'm out of luck. It just means that I have to pick a point that's independent of the vertex and 0, 0. And so I'm just going to pick the next easiest point to deal with, 4, 6. Notice that I labeled the point 4, 6 based on 0, 0, but it had no bearing on determining the vertex value of 6 for my x-coordinate. So I am good to sub that in. When my y value is 6, my x value is 4. And I can maybe jump to that, of which then we could go through and we could calculate, and we get down to there. Now, since I have two equations, we should be good to be able to solve that system. And all I'm going to do is I'm going to come up into this space here, because we could then take equation 1 and equation 2, both have k's in it. And so if I took equation 2 and I subtracted equation 1, then I'm going to have 6 subtract 0. I'm going to have 4a subtract 36a. And then I'm going to have k subtract k, cancels out. Now, the nice thing is I can divide out my negative 32, so I'm going to get a negative, and then I'm going to reduce that fraction, and I get down to 3/16. Okay, why was that useful? Because now I found my a value. I'm going to now take that a value of negative 3/16, and I'm going to sub it back in. It doesn't matter which equation you want to sub it back into. Maybe I just sub it back into 1 because I see the 0 over there. So I have 36 times negative 3/16. I can do a little cross-reducing here, that I can divide that by 4 and divide that by 4. And so I get 0 equals a negative 27/4. And therefore my k value is 27/4. And there we go. I'm just going to get rid of that little dot. Well, now that we've got that, we can actually build the equation of that parabola. And so I know that my equation then has an a value of negative 3/16 and has a k value of positive 27/4. So I just want to stop there for 1 second. I'm going to make it a little bit smaller just so we have a little bit more room. We clearly haven't answered the question that we've been asked. But there are a couple things that I have that it can at least act as somewhat confirmation. The first thing I can look at is I have a negative a value, so that confirms that my parabola is opening down. The second thing I have is I do have my y-coordinate of my vertex. So I'm just going to write up in the top right corner that I actually found that the vertex of this parabola is at that. And so if I went through, 4 goes into 27, that's going to end up being 6 times with 3 left over. So we're going to end up getting 6 and 6.75 is my vertex. So at the very least then, I know height-wise, I've got a little bit of space above my truck. Okay, now what I need to do is I need to go through and I need to work with the information in the problem. That really what I need to figure out is, and I'm going to try to just do this on this diagram as clear as I can, that I know that for the truck to be able to pass, it would have to pass in the middle, where the height is the most on the tunnel. And so if my truck was centered in the middle, then that would be the best opportunity for that truck to fit. I know that my truck has a height of 6.25 meters. And so really what I want to find out is, for what x values does my curve have a y value of 6.25? So I've got a little bit of work to do, and I'm going to come over onto this. What I'm going to do now is I'm going to sub a y value of 6.25 into that function. Now, depending on how you want to work with this, depending on your numbers, you might choose fractions, you might choose decimals. For me, it's a little bit easier to work with fractions because then it's always an exact value. So if I was to change 6.25, I know that that would be 25 quarters. So I'm going to replace my y with 25 fourths. And now I have the rest of my function. And my job now is to solve for x. Okay, so the first thing I need to do, I notice that my x is in one spot. So I want to isolate it, which means I need to get rid of this last term. So I need to subtract out a 27 fourths. If I subtract a 27 fourths, then I'm going to get a negative 2 fourths. And I hope that I can skip that step a little bit because you recognize that negative 2 fourths is going to reduce to a negative 1/2. Okay, now that I have that, I can get rid of my a value. So I'm going to multiply out my 16 and I'm going to divide out that negative 3. So that's going to give me a 16 sixths is equal to x minus 6 squared. Now, as we work our way through that, we should notice that that fraction is going to reduce. And so for a lot of us, we would have skipped that step and we would have just come right in on 8/3. Okay, next thing to get rid of is my squared. I know to get rid of a squared means I take the square root. And when I take the square root, I know I'm going to get two answers. So I get plus or minus, and the square root of 8 can be reduced to 2 root 2 over the square root of 3. Now, my problem is that is a hideous looking thing because we recognize that you have a radical on the bottom, and we know that we can't have that. So we need to rationalize that denominator. So we're going to multiply that by the form of 1, so root 3 over root 3. That's going to be most useful to us. And so I end up getting then a plus or minus 2 root 6 thirds. Okay, we're almost there. So now to get the x all by itself, I have to get rid of that minus 6. Which means I'm going to add 6. And then to get a common denominator and simplify it into one term, we get down to that point. Nice. Now, that shouldn't surprise anybody that we get down to that because I could have had an awful lot of people that would have went right back to that first yellow line that I just starred, and they wouldn't have solved that equation that way. Instead, they would have chosen to expand all those brackets, collect like terms. You'll notice then, with the star of my final solution, that looks an awful lot like the solution I would get had I used quadratic formula. Okay, regardless of how you wanted to do that, we get down to that point. However, this is an application question, and so we can go through and we can round those off. I'm just going to shrink this down one more time to make a little bit more room. And when we get our approximate solutions, we're going to then end up getting that x could be approximately in the plus case 7.63 or in the minus case 4.37. Now, when we do get to that point, we haven't answered the question yet. That question asking, can a truck of that height pass through the tunnel? Now, I'm going to blow this back up on my diagram, so I know that we got a lot of moving around here. But what that means then is that I now know this coordinate and I know this coordinate. So if I was to shrink this, again, just to give us a little bit more room, and I'm now just going to write those coordinates down, what I actually have in this case then is a point that exists at 4.37 and 6.25, and a point that exists at 7.63 and 6.25. So, are those points wide enough across to fit that truck? Well, my quick calculation then is to take 7.63 and subtract 4.37. And when I do that, I get 3.26. How wide was the truck? It was 3.5 meters. And I only have a width of 3.26 meters to fit that truck, and therefore my big answer is no. Okay, that was a ton of stuff that we just threw at you today for really only 2 problems. Your job is to play around with some of those stretch problems today, the ones that get a little quirky, the ones that maybe you don't have as much experience with. Play through them. See if we can consolidate our stuff about quadratic problems before we move on to a different area. Okay, best of luck with your practice.